right, so in this lesson, we learned how to use words in order to represent numbers. Okay, and then we learned to actually convert between those words and numbers. So I'm going to show you two real-world examples, and then I'm going to show you a chemistry-related one. Okay, so for number one, it says, if I have 1.4 reams of paper, how many pieces of paper is that? Well, I know that one ream of paper is 500 sheets of paper. Okay, so let's actually show that conversion. So my given here, and I'm not going to worry about sig figs in my final answer. I have 1.4 reams of paper. Okay, and I need to get that into sheets of paper. So I'm going to put reams of paper on bottom, and I'm going to put sheets of paper up top. I'm going to put sheets up here. Okay, and so I know that there are 500 sheets of paper in one ream of paper. So then what I need to do to solve this problem, I'm going to take 1.4 and multiply by 500. And what I end up getting is 700 sheets of paper. And that is my answer. Okay, let's look at one more real-world example and then get to a chemistry one. Okay. I have 3.5 pairs of shoes. How many pairs of shoes is this? So 3.5 pairs, kind of a random number, but okay. I'm going to put the unit I want to get out of on bottom, which in this case is pairs. And I want to get into number of shoes on top. So I'm going to just put shoes on top. Okay. And I know that one pair of shoes is 2 shoes. So then I'm going to take 3.5, multiply by 2, and I know that that will give me 7 shoes. So 3.5 pairs is 7 shoes. Yes, you could have done this in your head. The whole point is showing the setup and the conversion factors. Okay. Let's look at number 3. I have 2.4 moles of sodium oxide. Calculate the number of particles of sodium oxide I have, making sure to note what type of particle specifically we are dealing with. Well, I'm going to jump the gun on that and write out what particle that is. Na2O is an ionic compound, so I know that this is going to be formula units. If I'm counting how many of that compound I have, I'm going to be counting in formula units. Okay, so I have 2.4 moles I'm going to start with. Okay. I'm going to put moles on bottom, and I'm going to put formula units up top. I know that 1 mole is 6.02 times 10 to the 23rd formula units. So then what I'm going to do is I'm going to take 2.4 and multiply it by 6.02 times 10 to the 23rd. And the value that I get unrounded is 1.4448 times 10 to the 24th. Okay, I'm going to round this. I want to have 2 sig figs. This is 1, 2, 3. So I'm going to have 2 sig figs in my final answer. So this will just round to 1.4 times 10 to the 24th. And my units are formula units. All right, let's look at one last problem. It tells me I have 9.05 times 10 to the 22nd atoms of chlorine. Okay, so that is my given. And it asks me how many moles is that. So I want to get out of atoms, and so I'm going to do that by putting the unit atoms on bottom. So atoms is going to go on bottom, and moles are going to go up top. And I know, based on Avogadro's number, that 1 mole is 6.02 times 10 to the 23rd atoms. Okay, so now I need to take in my calculator 9.05 times 10 to the 22nd, and I'm going to divide that by, in parentheses, make sure your 6.02 times 10 to the 23rd is in parentheses, or else the times 10 to the 23rd is going to mess up your answer. 6.02 times 10 to the 23rd, close my parentheses, and the answer that I get, unrounded, is 1.503 times 10 to the negative first, which is also the same thing as saying 0.15033 in standard notation. Okay? As far as significant figures are concerned, I need to have 1, 2, 3 sig figs. 1, 2, 3. So this is going to round. 1, 2, 3. So your answer is either going to be 1.50 times 10 to the negative first moles, or it is going to be 0.150 moles. And that's your answer.